Hey guys, welcome to Pre-Calc, lesson 8A.1, exponent properties and evaluating. Let's start with a little review of exponents and evaluating bases. First one, 2 cubed. Hopefully you guys remember, 2 cubed just means 2 times 2 times 2, which we can evaluate simply to be 8. X to the 5th, we were just to expand that as x times x times x times x times x. X to the 4th times x cubed would look something like this. Here's x to the 4th times, here's x cubed. And what happens when you multiply those, as you can see, we have x to the 7th. We have 7 of those. That's going to lead us into one of our properties of exponents. X to the 4th cubed is x to the 4th times x to the 4th times x to the 4th. So using the previous problem as an example, that would give me x to the 12th. Two very different properties illustrated in these two examples right here. In number 5, 3 to the 9th over 3 to the 7th, that's easy to evaluate without a calculator. You don't need to evaluate 3 to the 9th or 3 to the 7th, as long as you understand that these 7 3's would cancel 7 of those, so you're just left with 2. So 3 squared is just 9. Here again, if you picture what x to the 10th looks like, x times x times x, so on and so forth, 10 times, that's x times x times x times x. These 4 cancel with 4 of those, so you're just left with 6. That is x to the 6th. Likewise here, 4 of those cancel with 4 of those, so we're left with x cubed, so that's 1 over x cubed, which is x to the negative 3. So another property of exponents there we're going to go over momentarily. So this is it. You must know these backwards, forwards. Product of your bases. What you do in this case is you add your exponents. So this would be x to the a plus b. When you divide your bases, you subtract your exponents. This would be x to the a minus b. A negative exponent, if you remember, takes the reciprocal of your base. So this is 1 over x to the a power, which is equivalent to 1 over x to the a. When you take a power to a power, you multiply those exponents. This would give you x to the a times b. Anything to the 0 power is just 1. Our last one, a rational exponent. What you have to remember here is at the bottom, the denominator is the root. Think of a tree, the bottom is the root, and the top is the power. So when you see this rational exponent, that is equivalent to the b root of x to the a power. Or what you can do first, you can take the b root of x and take that whole thing to the a power. Both of those are equivalent. Okay, let's start simplifying. This is about as challenging as it's going to get. Please don't try and do this in one step. It's very helpful to write things out. What I usually like to do is deal with my negative exponents first. So as I look at this expression here, there's only one term that has a negative exponent. It's only the y. Remember, the 6 is not affected by that exponent. So what I would probably do here is cross that out and write it down in the denominator. A negative exponent takes the reciprocal. So if you're part of a fraction and you have a negative exponent, you just move from numerator to denominator. Or if you're in the denominator with a negative exponent, you move that to the numerator. So now this expression is 6y to the 4th over 3y to the 5th, applying those rules from the previous page. And now I can simplify, right? 6 over 3 is simply going to be 2 over 1. And 4 of those will go into that, and I'd have 1 left. So that will simplify to 2 over y. All right, in example 2, we've got a lot going on here. First thing I want to take care of is my negative exponents. I'll move this to the denominator as c to the 4th. I'll move the a to the denominator as a squared. And I'll move this b to the negative 4 to the numerator as b to the 4th. All right, so cross this out. Let's bring it down, c to the 4th. Let's cross that out, bring it down as a squared. And then this b to the negative 4, I'll bring up top as b to the 4th. So what I'll do next is I'll clean this up. Let's clean that up. and then we'll combine all of those, see what we get. I have 8ab squared times negative 4b to the fifth c all over negative 64 a to the fifth. There's no b term, and then I have c to the sixth. And now let's take a second to simplify that numerator. 8 times negative 4 is negative 32. A b squared times b to the fifth is b to the seventh. And then I have a c. My denominator is still negative 64. A to the fifth, c to the sixth. And lastly, let's simplify here. Those negatives will cancel. 32 goes into 64 twice. So I have a 2 in the denominator. With my a's, I have a over a to the fifth. So this will cancel with one of those and give me a to the fourth in the denominator. There's no b in the denominator, so I have b to the seventh up top. And then c goes into one of those, and I have c to the fifth in the denominator. So finally, that expression has been simplified. Okay, example 3, we have to be careful using our properties. I am multiplying the bases, but remember what happens when we do this. I don't actually multiply 6 times 6. The rule is when you multiply the bases, you add the exponents. So this is going to be 6 to the 7x. And that's all we can do to simplify that expression. Same here with this one. Don't multiply 2 times 2. If that was x to the 10y times x to the negative 6y, your base stays x. So in this case, the base stays 2. And then what we do is we combine or add our exponents. So 10y plus negative 6y is just 4y. All right, example 5. I see some negative exponents. So remember how we handle that. This will go to the denominator. This will go to the denominator. And that will go to the numerator. So the first thing I like to do is just rewrite those. So I'm trying to simplify. So I have a 16 in the numerator, 48 in the denominator. I have an m to the 1, or the first, goes in the denominator. An n cubed goes to the denominator. And then I have an m down there from before. And that n to the negative 5 goes to the numerator as n to the fifth. So deal with all the negatives first. Then we can start simplifying. All right, 16 goes into 48 3 times. So I have a 3 in the denominator. Up top, I have n to the fifth. And in the denominator, I have n cubed. So I have an n squared in the numerator. And then in the denominator, I have m times m, which is m squared. So there's my simplified expression. All right, the next one is a combination of, I've got negative exponents, I've got fractional exponents, but remember, the process is the same. I'm multiplying my bases, which means I am going to add my exponents. So we just have to get good at adding fractions, that's all. Now, 3 times 1 is just going to be 3, so I'll write it down here. X to the, add your exponents. Negative 4 plus a negative 2 is negative 6. Y to the, add those exponents. 5/3 plus 1/3 is 6/3. Now I'm doing this slowly because I want to simplify this expression. What I'm going to have here is a 3y squared in the numerator, x to the sixth in the denominator. Notice that negative exponent means that this term will go to the denominator, and I can simplify 6 over 3 as 2. So there's my simplified expression. All right, moving on to fractional exponents and bases that we should be very familiar with. We were supposed to do this last year in Algebra 2, but that kind of got altered by COVID, obviously. So we need to know our what we call power families. Power family of 2, power family of 3, 4, 5. So 9 to the 1/2 power, you need to immediately recognize as square root 9. Because remember, the numerator is the power, the bottom is the root. And a square root is the second root. So we don't usually write the 2 in there, but we need to know that's simply square root. So obviously that's 3. Now, 8 to the 2/3 means cube root of 8, and then you're going to square it. Generally, we like to do the root first. Why is that? Because the number gets smaller. This is a power family of 2. The cube root of 8 is 2. And then you have to square it. 2 squared is 4. 27 to the 4 thirds. So that's going to be the cube root of 27. Whatever that base is, then you take it to the 4th power. Cube root of 27 is 3, and you should know 3 to the 4th without using a calculator. Think of it as 3 squared times 3 squared, or 27 times 3. That's 81. Now this one, we don't have to play around with the bases at all. It's just an x. X to the 2 thirds times x to the 4 thirds. Let's add those. That gives me x to the 6 thirds. And then 6 thirds is simply a 2. So that's x squared. Okay, next page. Let's wrap it up here. Some more properties we'll go through quickly here. This one's very similar to the one we just did. X to the 5 thirds times x to the 4 thirds. We're going to add those exponents. That's x to the 9 thirds. And 9 divided by 3 is simply 3. So that's x cubed. Here, x to the 3 halves times x to the 5 halves is going to be x to the 8 halves, which is simply x to the 4th. 2 to the 5 halves times 2 to the 5 halves is 2 to the 10 halves, which is 2 to the 5th, which is a number you should know. 2 to any power is relatively easy. Use your fingers. So, for example, doubling. 2 times 2. So that's the 2nd power. Then you go times 2. All right, so that's 8. Then times 2, that's 16. Then times 2, that's 32. That's 5 powers of 2. So 2 to the 5th is 32. Now this one I can't combine because notice here bases are the same, bases are the same, bases are the same, so I can apply my properties of exponents. But here the bases are different. So what we're going to do here is work with each one of these independently. So 4 to the 3 halves is the square root of 4 cubed times 16 to the 5 fourths is the 4th root of 16 to the 5th power. So square root of 4 is 2, and then I'll do 2 cubed, and that's 8. 4th root of 16 is 2, and then 2 to the 5th is 32. All right, 8 times 32 is 256. Now, if you didn't like doing it in that order, you could have gone here and said, well, 2 cubed times 2 to the 5th is 2 to the 8th. And then just keep doubling. Okay, 2 times 2, so I have 4, then 8, then 16, then 32, 64, 128, 256. Count them on your fingers, and that's how you get there without a calculator. Next one, 27 to the 2 thirds divided by 3 to the negative 2. So our negative exponent here, I would bring that up. So this expression is the same as, I'll do this, cube root of 27 squared times 3 squared. Cube root of 27 is 3, so that's 3 squared times 3 squared, 9 times 9, that is 81. All right, so let's work with more of these rational exponents. Example 10, I want to write each in radical form. So I want to eliminate any fractional exponent. So 3 times x to the 6 fifths, this is going to be 3. Remember, this exponent here only goes to the x. It does not go to the number out in front. There's no parentheses. So this will be 3 times the 5th root of x to the 6th. The next one, negative 2/7. So this exponent does two things. Number one, it's a negative exponent, so I'll make this go to the denominator. And then I've got the 7th root, and the power is 2. So this expression would be negative 2 over the 7th root of x squared. This one here is similar to the one we just did. I've got 2 fifths to start, x to the negative 4/7. So that's going to go to the denominator. It'll be 7th root of x to the 4th. So 2 over 5 times the 7th root of x to the 4th. And the last couple, write in simplest exponential form. So now I don't want any radical whatsoever. If you notice here, I'm taking the cube root of all of these inside. So this will just go into the exponent as a denominator of 3. And again, I don't try to do too much simplifying up front. So this will just be 3 times x to the 2/3, y to the 6/3, z to the negative 3/3. Now remember, the reason that this exponent is negative because z is in the denominator. And then I try and simplify any of these that I can. So obviously I can't simplify 2/3, but I can simplify that to a 2, and I can simplify that to a -1. And just rewrite that as your simplified answer. 3 x to the 2/3, y squared, z to the -1. And finally, this one here. Notice this root only applies to the x and the z, not the y. But this is in the denominator. So I'm going to have 1/4. I have x to the 8/4, z to the 2/4, y to the -2. And then we just need to simplify these fractions right here. That'll give me 1/4 x squared. I like to put these in alphabetical order. So y to the -2, and then z to the 1/2. All right, so that concludes day 1. Thanks for watching, guys. As usual, reach out if you have any questions, and we'll see you in class soon.